So first of all, everybody, thank you so much for coming back. I know it was a gorgeous sunny day outside, and I'm guessing it was probably pretty tempting to just hang out outside for a little bit longer. But we have a great action-packed afternoon. The next three sessions the morning was, I think, really focused on getting everybody on the same page and also introducing, making some introductions. We just had started talking about the service provider use cases, but this afternoon, the real goal here is to go kind of use case, pain point. A piece that I think a lot of folks here were really kind of signed up to do. So we think of the morning really as preparation and afternoon for this afternoon. So let me start. We're going to start here from a little bit after 1 to 2. We're going to go about an hour with sort of an interview style Q&A session, right, with Matt Davy. I think we've got some exciting things there. Then we'll move over to infrastructure as a service. Then we'll talk about enterprise data center, and then we'll do a wrap up. So to get things kicked off, Matt, do you just want to, unfortunately your plane was late, so we couldn't quite get you into the round of introductions this morning. Do you want to start out by just giving the audience a sense of where you're coming from?
Sure. So my name is Matt Davy. I'm with Indiana University. Actually, listening to Chris's talk before lunch there actually brought up a lot of memories. So I started my career in the service provider realm, actually at AOL and then UNet. And much of my time at IU has also been spent in wide area networks. So the Internet 2 network is near and dear to me. So we have this thing called the Global NOC at Indiana. Basically, we run, we manage parts of or all of a variety of different networks in the university's nonprofit space. So Internet 2 being one of those. So we do a lot of the management for that network. We actually have about 18 networks we do that for. So thousands of devices, lots of big, primarily wide area networks. So that's sort of one piece I've been doing for a long time. The last 4 or 5 years, so I have the title of network architect for the university. So I've spent a lot of time dealing with our enterprise network, and more recently, I'm a director of a Center for Network Research and Education that we started this spring.
And before we get into some of the campus LAN questions, I promised that the earlier setup with Chris, with you, and with you was we didn't set that up in advance. But I just wanted to see if you want to take a few minutes to go through the demo that you were talking about for the router interconnect case.
Sure. So one of the things in the university community is having these super large research data sets that you need to move around. So there's been a lot of interest in building dynamic paths across the network that basically reserve bandwidth for a specific application. So you have a multi-terabyte data set you need to move around. You kind of want to open a connection, provision a path, and do that. So the thing that we demoed 2 weeks ago for the first time, it's a project called NDDI. If you search for Internet 2 NDDI, you can find some information. But basically, it's a user-based, a web interface where users can provision their own paths across the network. A lot like Chris was talking about, you can pick the endpoints you want to go between. Provisions a primary path, provisions a redundant path, can guarantee bandwidth, although we don't have the back end of that working yet. But it's all based on open flow. It's all open source. We use the NOx controller. We're using switches that we're buying from NEC. So a top-of-rack switch model. So basically, user can go in, they can pick a path, they can provision it, and it uses open flow to go provision that underneath. And so the plan, it's in beta right now for customers to start using, and plan to go production shortly after its first year.
So over the last couple of years, at least since I've gotten involved in the open flow effort, you've sort of been the person who's demoed things 6 to 12 months before they're out in the market. I'm just curious to get a little bit of a sense of the history here and some of the other pilots and production builds and demos that you've been a part of.
Sure. We got started in this almost, I guess, 2 years ago, and the first deployment we did was for the GENI project, which stands for the Global Environment for Network Innovation. It's an NSF project. So, a lot of the work that was done here at Stanford was help make that happen. So it uses the FlowVisor software to basically slice up the network, and the kind of crazy, interesting part is that the idea is that you run a FlowVisor for your infrastructure, and then you let other researchers, potentially at other institutions, run their controller against a slice of your infrastructure, which is pretty scary as someone who spent a lot of time running large production infrastructures. But it's kind of cool. It's one of those kind of crazy cool things that you can do when you work for a university. So we have three deployments there that we're supporting. So we have a 5-node deployment nationally on the Internet 2 backbone, another 5-node deployment on the National Lambda Rail backbone, and then we have a deployment locally to the Indiana University campus. So we manage all of those, manage flow visors. On the campus, we also have a deployment of HP switches, actually the big switch controller, that we're putting sort of production users on. So sort of the start of rolling out how can we use this in production on the campus network. We're sort of eating our own dog food. We're deploying it in our building first. So we all get used to it, but we have other schools and departments lined up so we can roll that out as we get more comfortable with it. I mentioned the NDDI infrastructure, so that's currently has 4 nodes in the field. The plan is to grow that to about 35 nodes nationwide over the next year. We're also developing some other production software to do load balancing function for us as well that we're not quite ready to talk about in demo yet, but that's coming up in 2 weeks. We demo that.
I think people have said that over courses of the history of OpenFlow, you've actually represented a significant percentage of the worldwide pilots of OpenFlow. When you see this massive list, it's more than just figure speak. Now, I remember us talking when we first started going down the path. It was over a year ago. You talked about virtual networks that you had set up on the campus using other needs. You talked about 6 campus, multi-campus virtual networks, and we talked about 4 data center networks you'd set up. I'm guessing that the rest of the audience would be really interested in hearing how do you build out these virtual networks before OpenFlow? And then what's your vision for how you manage them afterwards OpenFlow?
So maybe I should start by explaining sort of the environment that we deal in, because I think if you don't run a large university network, it's kind of hard to understand some of the challenges that we deal with. So maybe talk about some of the challenges there. So Indiana University has 8 campuses around the state. We have a major campus in Bloomington, sort of the traditional campus, residential, 42,000 students. About 14,000 of those live in residence halls. So yes, I have about 10,000 gaming systems on our network, and about 25 or 30,000 iPhones or other smartphones. So you have a lot of challenges associated with that. 42,000. Actually these days more than 42,000, roughly double that. Everyone has a laptop and a smartphone or whatever that are managed by the students. We have no control over those. At the same time, we have high-performance computing systems. I have a system that can write data from the IP network to disk at 120 gigabits per second. At the same time, we have financial systems, HR systems, all those other things, right? So you have that to deal with. Our Indianapolis campus has about 30,000 students, a big medical campus. I have doctor's offices that we manage networks for, hospitals, all of those things connected to a network there. So we have about 1,700 switches, 100,000 switch ports across our 8 campuses, 4,500 access points. But what makes it really interesting and why I sort of moved from my focus from the wide area to the campus space is the diversity and how you deal with the diversity. How do you deal with the fact that I have over 100,000 students that all manage their own machines connecting to a network that also has my HR systems and my finance systems and these crazy high-performance computing systems that can move tons of bandwidth. I have 500 buildings. They all have HVAC systems and electrical meters and all those things. I have roughly 600 payment card systems, point-of-sale systems, right? We have a very centralized, we try to centralize the infrastructure parts of our IT. So obviously, much like the big multi-tenant data centers, you want to build one big, fast infrastructure and then support all those uses on there. So how do you do that, right? 12 years ago when I started here, we did it by doing VLANs, right? If you wanted, and you use VLANs for sort of security segmentation, right? So if you wanted to put all your payment card systems on one network, you just, plumb the VLAN all over the place, right? Well, clearly with 8 campuses, 500 buildings, that just doesn't scale. You can't, there's just so many problems with that. So the way we do it today is you build basically a number of VLANs out in every building. So every building has a payment card VLAN, every building has a building automation system VLAN. Then you tie all those together with RFC 2547 VPNs in the core. So every time, we have about 6 of these that we've rolled out. We have one for PCI DSS. We have one for our medical system, for all the hospitals and all the medical stuff. One for building automation. So we've rolled these things out. We did a similar thing in our data center. So we have started virtualizing in our data center, bringing all those servers that had been sprawled around in all departments, maintained under assistants' desks or in a closet down the hall. Those are all starting to move back to VMs in our data center. We have about 1,500 VMs in our data center now, so that we have the multi-tenancy problem in our data center. So we took that same architecture, built it out in our data center with MPLS VPNs. The whole point of the MPLS VPNs is to group all that traffic up so you can pass it through a firewall or whatever the devices are you need to pass it for to be in compliance with the policies that you need to be in compliance with. That's the whole point. That's the only reason we do it. So today, to roll one of those out, so you have to go, provision a firewall context on the firewall. You have to provision a new MPLS VPN. You have to go out to possibly 100, 200, 300 buildings, provision VLANs down to all the data jacks you need to provision those down to. It takes months to roll out a new virtual network. And just the overhead to maintain those and the operations of those, we've been doing this for about 3 years now. We really don't think we can commit to deploying more than 10 or 15 of these things just from the support time of supporting those. We need to be able to deploy 300 of these things. You have departments, schools that are spread across 3, 4, 5 different buildings. They want to group all their machines up and pass them through a single firewall instance that they have some control over the rule set of. We cannot scale the current architecture from an OpEx standpoint. Just the time and the people time it takes to provision all that and maintain all that, far past where we are today.
I mean, this to us seems like one of these moments of OpenFlow is not a technology. OpenFlow is a solution to a very, very significant material problem. I'm curious. You mentioned that hey, you can't commit to supporting more than 10 to 15 of these. What do some of the day-to-day problems look like that are just chewing up members of your team?
Well, I mean, one of them comes down to sort of delegated control, right? So we maintain the infrastructure, right? There are local IT support providers in every school and department that are responsible for managing the systems, the VMs, all the things for that department. They have all the information about that they need to go support the networks out, the firewall rules, their IDS, whatever they need to do. Yet, if we run the infrastructure, they basically have to pass all that through us today to make that happen. And so just maintaining the rule sets, the compliance, the audit logs, all those things for all of these different systems, we have no way to push that today out to all those departments. They have to do the work once, because they have to go figure out what the rules are, and then they have to pass it all to us to actually go implement what they already know they need to do. So I think that's probably the biggest piece that needs up time. We estimate roughly a full-time network engineer just to handle PCI DSS compliance.
I was going to say that the IU PCI compliance use case is actually one that a lot of people repeat at this point. I think in many ways because of the story. This to me became almost like the canonical use case for OpenFlow on the campus LAN. I was curious, would you be able to go into a little bit more detail around it?
Sure. This came up about 3-4 years ago for us when we went through our first PCI DSS audit. I was pretty intimately involved with that. And you don't realize all these things that plug into your network. I'm sure carriers have the same thing. Lots of things plug into your network. You don't actually know what they all are. And then I started figuring out sort of what all this involved. That we had hundreds and hundreds of these systems and dozens of VMs. And in our case, actually managed by about 10 or 12 different organizations within the university that each manage their own compliance. They manage their own point-of-sale devices. They manage their own servers. They're spread across hundreds of different buildings across all 8 campuses. And if anyone has dealt with PCI DSS compliance, you'll know it's extremely prescriptive, down to exactly the kind of equipment you need to use, exactly the kind of firewall policies you need to implement. It's pretty onerous. And so to think about how you put in place uniform policies to cover all those systems across all that infrastructure, and then maintain those in a way that is auditable over time, you really have to consolidate that all back to one entry point into that network. But again, you really want to be able to push a lot of that out to the local support providers who already have to maintain all the compliance information for their servers and other things. The network all comes back on us because I have no way to delegate all that. We really need to get to where we manage our network in a different way than we do today. I mean, I've been managing networks on a large scale for a little over 15 years now, and I have to say that the way we manage networks today is not all that different than the way we managed networks 15 years ago. In the end, a lot of it comes down to a smart guy sitting down at a keyboard and typing stuff into individual elements. And what really got me excited about OpenFlow when I first learned about it was, it goes back probably 6 or 7 years. I had lunch with Doug Comer from Purdue, if you know him. Wrote a great textbook on TCP/IP, which I think a lot of people took their first networking courses from. And he said something that stuck with me, which was, we need to manage entire networks the way we manage individual nodes today. There's no way we're going to scale the network to the way we need to scale it to unless we get to that paradigm. And about 3 or 4 years ago, when I first started playing with the first controller-based wireless solution, I had that sort of aha moment where you go, you know what, this is not network management the way I thought of network management. It's not S&P, it's not NetConf, it's not some piece of software that's glommed on to the network after it's built. It's baked into the network. You centralize points to those control planes, and today, for me to configure a new SSID across hundreds of buildings takes seconds. I need to make a change to an SSID, it takes seconds. You go in, make a change to the SSID, and it just propagates. When I have techs go out and plug APs into the wall, they don't have to go find the config file and find the right firmware and upgrade it and put it in place. And so 4 or 5 years ago, I guess 4 years ago when I first started playing with this, I went to our vendors and said, well, geez, this controller thing's great. It works great for my access points. When are all my closet switches going to connect to that same controller and do all the same things? Because I have the same problems over there. And actually, a lot of them looked at me really funny and thought, what the heck is he talking about? In fact, some of my network engineers, one in particular, I mean, he thought I was nuts. Like, why the heck would you want a controller for your wired network? And then, so when I saw OpenFlow, I thought, okay, well, this is a big piece of it, right? This is the control plane piece. I mean, we still need the management plane piece. That's not really there. The ONF is working on the config management protocol stuff now, but that was the sort of, that's where we need to get to. We need to manage the whole network just like we manage nodes today.
I was going to say, so Eric had a question earlier about what's the difference between, you scope projects on both sides, a major network automation project and a major automation project using OpenFlow. I think we had a good dialogue going earlier about, so what's the difference? I mean, you've seen both of these things.
So I actually asked our developers a week before we did the demo, so about 3 weeks ago after they demoed the NDDI software, provisioning software to me, and I said, so they had gone and built this. They built it against another vendor's platform using current sort of NMS techniques, and then they essentially rebuilt it using OpenFlow. I said, so what was your experience? What was the difference, and how did it go? And they said, we were surprised at how quick it went. It was just a lot faster, a lot easier to develop that functionality. And they could do things that they couldn't do in the other platform. So we built full redundancy into the controller. So we built a whole layer on top of Knox that basically has a virtual IP. So the whole application layer, the database is all synced between the two controllers, and it all fails over. Calculating all the backup paths and automatically provisioning all of those and failing over to those. There are just things that are either a lot easier or in some things you just couldn't do in the other architecture.
Yeah. I mean, not to put you too much on the spot here, but is this the difference between, say, a couple of man months and a couple of man years, or is this a...
Yeah, I think so. I mean, I've talked to a lot of vendors about this. Some of my early conversations, I tended to get, well, if you had policy-based routing, you could do that. And then I'd give another case, and they said, well, if you had this feature and that feature and that feature, you could do that. And I'd give another use case, and they said, well, if you had these other 2, 3 features, you could do that. And it's like, well, yes, but all of those are easier in this context. And it's sort of one solution fits all. It's like you could technically build a network management system that does a lot of things a wireless controller does. But has anyone ever done it? No, they didn't do it. It's a heck of a lot easier to do it if you have a controller in the picture. And so I think that's the key. I talked about the PCI DSS scenario. And I had a lot of people say, well, if you had radius authentication to all the switch ports, you could automatically put things into VLAN, and there's these other protocols for dynamically building out VLAN, so you don't have to configure them. And if you wave a dead chicken over it and stand on your head, it'll all work in the end. That's not a solution to my problems. We spent 9 months trying to get all that dynamic VLAN radius stuff working, and it didn't work in the end. So we need a way that builds a platform that makes this easier.
I always ask, for somebody who's as far along as you are, with folks who are kind of just early stage, and I say, about to the 20% of the audience who kind of represents a little bit more, hey, customers thinking about how would I get started with OpenFlow? How do you start down the path? What are the first couple steps?
That's a good question. That wasn't on your list, was it? I don't remember reading that one on the plane this morning.
I gotta keep it interesting.
There are ways to play with this that are actually pretty simple and don't involve a lot of investment. So we brought a whole bunch of students on board in the last 6 months. And so we've had a lot of, and staff too, and we've had a lot of people to get up to speed. So, there's a tutorial going on in the other room to, get you up to speed on using, Mininet and VMs, and build this all on your laptop. So when I started, I just turned it all up on my laptop and started playing with it. So, that's a really easy, simple way. And I think it really gives you, you can start seeing the kind of things that are possible once you start playing with it. So, you guys, big switch, you're playing with your controller on a VM, everything fits in a VM, you just run it on your laptop. Quick, easy way to get started up. And I think you can really get a lot of the concepts out of it. I think the real value comes, though, in all the software that gets built. I think, as you said earlier, OpenFlow is just one little piece in there. And the real value is in all the software that's going to get built and is being built on top of that. So really understanding where folks are going with controllers to understand, what those are going to be capable of, but also to understand, I think really important, the API into those, right? Because it's really, as I have a conversation on the way to lunch, it's really that API northbound out of the controller that's going to allow you to go integrate this with your network. Because I don't know about others, but in our networks, none of the solutions that a vendor ever provides exactly what you want to do. You have all sorts of back-end systems that you want to be able to tie this into and customize it around. We build, user interfaces for our security office, user interfaces for our support center. There's all things you want to customize, so it's really important that you be able to build your own customization on top of whatever platform it is that you choose.
Yeah, so I have one question that I asked to all of the other panelists this morning, which I'll ask, but I think we actually do have a couple minutes to take some questions from the audience. After we take those questions, my final question will be, can you make a prediction about, okay, if we're sitting here a year from now, what are some of the major milestones that will have happened? But before you go into that, why don't we first just see if there's a couple questions from the audience, and we'll start there.
Matt, did you have IPv6 requirements, and if so, how did you deal with them?
So we don't have IPv6 requirements today. So it depends what you're doing with OpenFlow, right? So the NDDI example I gave, it's a layer 2 provisioning system. It doesn't care what package you stick inside of it. So that has not been a requirement for us. Being a university and the fact that we actually have 12/16 IPv4 addresses assigned to us, there are certain aspects of IPv6 we're not worried about. Mainly, we just want to get our public-facing servers IPv6 enabled, and we're not touching certain things with that today with OpenFlow. So, we haven't had those requirements yet. So we're, anxiously awaiting standards that will make that possible. So when we do have requirements, we can go.
Peter Christie, Internet Research Group. On your virtual network management problem you were describing, how much do you expect that you want to get from vendors, and how much of that do you feel comfortable you could roll your own with whatever internal resources and settings you have?
I think that'll depend on what ultimately becomes available. It's good to have commercial options and commercial support there, especially with a network of that size. In order to scale out the controllers, as we've seen with wireless controllers, for example, we have 32 of those to spread the load out. If we need 5, 6, 7 controllers, as Kyle mentioned, developing sophisticated distributed systems is difficult, and it would depend whether we thought we had the staff to do that. I think we would prefer to have a platform that provides base functionality that then we can extend through APIs to customize to what we want to do. I think that would be the preferred solution.
You talk about virtualization, and then you talk about the wireless APs. My question is, what did you do with the wireless APs? Did you do wireless virtualization? And if so, what do you mean by wireless virtualization?
Do you mind naming it for you?
Jason Lee Intelligent Automation.
Well, I sort of see the wireless as virtualization in terms of multiple SSIDs, for example. So the paradigm I see is I can go into my wireless controllers and I can configure an SSID. And actually, our controllers, they're called virtual something instances. I forget what the term they used. It's not actually an SSID. I can configure all the parameters of that service and then just associate physical assets with that, associate radios with it. And I can configure multiple instances and have different slices, different physical assets associated with different SSIDs. And so I think if you extend that paradigm to the wired network, right, I want to create a virtual switch instance and configure all the parameters that belong in a virtual switch and then associate physical assets with that virtual instance. So I think the analogy is pretty similar.
Okay, so the same analogy, you're not really virtualizing the wireless radio resources in terms of radio.
No.
You're really virtualizing the IDs and mappings between the physical instance, well, the virtual instances and the physical APs, basically.
Yes.
Hi, Sarwar Raza from HP. So, question of scale. If you're looking at, you probably have this issue today. You've got campuses of varying sizes, from tens of thousands to probably, support facilities that only have 4 switches in them, right? That need support. As you look out to, a controller-driven future, where you have multiple controllers, how do you decide what the scope, in terms of the number of devices or the types of devices a controller is managing? How do you decide where that line is drawn? Is it just X number of devices per controller? Is it a more logical breakout by function? Is it I'm interested in your thoughts on how that might work.
Well, I mean, partially you're gonna build it out with redundancy in mind, right? So if you have multiple locations, you want to make sure potentially that you have at least one controller, depending on your failure points, closer to the switches they're managing. Aside from that, when you're looking at, say, one of our big campuses where we have 300 buildings and 1,000 switches, you look at something like that, you're probably just going to slice it up by numbers. And do it that way. It's very similar to how we do wireless today.
Yes, I had a question about, Art Fuel. I am here for Network World and SiliconANGLE today, but I also work for Dell. And I had a question about the NDDI demo you're talking about. What are the initial primary interests and use cases that you see for that right now?
Well, I think there are a lot of different use cases for the software. So first, I should say that the service that we're providing is not a new service, right? So like I said, we had built this before on traditional sort of network management technology. And so the use cases there are varied. So with Internet 2, there's a backbone that is actually fairly limited. I think they only have 9 or 10 router nodes around the country, and then they rely on these regional networks to basically feed all the end universities into the backbone. So it's sort of a 3-tiered infrastructure. So the use cases vary. In some cases, they're one regional network that wants to build a layer 2 connection to another regional network to do disaster recovery, for example, for their campuses. In some cases, they want to provision all the way from the application, right? So they have a wide area file system, GPFS or LusterWinner or something like that, and they want to say, I want to fire up an 8 gigabit stream between these two endpoints. I want to make sure the network's provisioned with enough bandwidth on a given path to make that happen. And so they want to be able to signal all the way from the application to build that traffic engineered path across the backbone. So those are the use cases that have already been there, they've already been using. We just took the OpenFlow technology. Basically, we were tasked with going and building a new network to do this based on a sort of lower cost Ethernet switching, as opposed to Ethernet over MPLS, which is exactly the case that Chris was talking about this morning. And so when we looked at, hey, we're going to use Ethernet switches to build the same sort of thing, it was like, well, duh, then we would just use OpenFlow as the provisioning network. That makes the most sense. So we went and basically replicated a service that we were already doing on a new technology.
Sorry, I have to make all
Yeah, Eric Cho from Microsoft. So what's the biggest vulnerability you have today that you see in your OpenFlow enabled network? And if you could share some of the outages that you have as a result, or maybe related or unrelated. Is it the communication between controller to switches? Is it number of controllers that's been redundant, or what?
So with the NDDI infrastructure, we really don't have enough time to know that. If we're looking at our campus networks, it depends. Again, it comes back to what are you doing, proactive versus reactive. So we had run a number of campus networks in reactive mode. We're basically reactive mode, and gosh, all the same things that you could pull up that would be potential issues of overloading the path between the data plane and the control plane. I mean, we all know there has to be some proactivity in doing this. Doing 100% reactive to flows has issues around it. The question that always comes up is, well, aren't you putting all your eggs in one basket with the controller? And actually, I usually get this from the security context. Like, I say, well, let's see, I have credentials sitting on 1,700 switches today, and I'm going to move those credentials to 4 or 5 controllers. Yeah, there's fewer points to target, but there's also fewer points I have to secure. What's the chance of fat fingering or misconfiguring one of 1,700 switches versus one of 4 or 5 controllers? So I don't particularly see that as a vulnerability. I don't know, does that answer your question?
So how long have you had this total OpenFlow enabled network? And I guess it's just how much bake time did you have in it? And do you think that's enough time to kind of run through all the use cases and failure modes and so on and so forth?
I think so. So we've been running for 18 months now. And so we've identified a long list of things that we need to work on. In a lot of cases, the security of the OpenFlow channel, the encryption of the OpenFlow channel, it isn't there between the controllers and the switches that we're deploying. So our control channel, completely wide open. So there's a number of steps you have to take to mitigate that. Just because, it's in the protocol, you can do TLS, but it's just not supported today. So yeah, we've done it long enough. We know what they are. Some of them have workarounds today. Some of them are things that we're waiting on software for.
Yeah, Marcos Salvador from CPQD Brazil. I wonder if there is any lesson to be taken from what's happening to GMPLS control plane as a tool that also provides for automation. It's been around for years. I can tell from the Brazilian experience that we have developed rodents with optical control plane that our industrial partners have sold in thousands, and with GMPLS embedded, and nobody's using it because they are scared to death of using GMPLS and all the automation that it is capable of. So, do you think there is any lesson to be taken? terms of automation? I mean, is the automation the real argument, or is innovation the strong argument?
Yeah. At some point, you need to do things that you can't do without that. Actually, we had a conversation early on about user interface and whether OpenFlow controllers should have a traditional switch CLI to them. And I said, why the heck would you want to do that? Here you have a chance to run your control plane on a server that you can do much more powerful things with a GUI than you can from a command line. Why would you want to replicate the thing that we developed decades ago on this whole new technology? And operators have to get over this, right? They really do have to get over this. And I'm one of those guys. I've been typing at the command line or routers for years and years. But they have to get over the automation aspect of that. The server guys have gotten over it. The network router guys need to get over it too. And at some point you can't do it without the automation. They don't think twice about hitting the button to retune all the wireless radios in a dozen different buildings. In the last 3 years they've gotten over that, right? They used to want to go fine tune all the channels, and they didn't trust the automation to go get the right channels. Well, after a while, you realize when you have 5,000 of these things, you can't do that. You have to start trusting that when you push that button, the right thing happens on the back end.
Okay, I mean, we have also developed a GUI based on Oscars and so on. The customers can, ask for a circuit, and the circuit gets provided in a second and so on. Still, they're not buying to it. So I wonder if you guys have a better argument than we do. Because
Prasad Alanki, One Convergence. What about the latency problem, especially once you go up? Do you guys face any latency issues in terms of the?
Again, it depends what your application is, right? So you mean latency between the switch and the controller?
Correct. I mean, you get a packet, first connection.
I mean, so again, it depends what you're doing. Are you doing something proactively? If you're proactively populating rules, then the latency doesn't really matter. So we've stuck, to proactive. If you're trying to react to flows, then you have that issue. In the wide areas, especially, I mean, we're doing completely proactive.
But on some applications you do have reactive, right? Like if we're talking about load balancing, there's no application, and especially the web data centers, you have to do. There's no option on that reactive.
In our case, we're starting with a very simplistic load balancing scenario. For that reason, and really, it depends on the load. So part of the problem of reactive in the load balancing scenario is, without going into details about what we're doing yet, but it is really the bandwidth on the channel coming out of the data plane to the control plane. When you're dealing with 100 packets per second out of the data plane to the control plane, that's just not going to work. I mean, we have to get the switch architectures if this is going to work. That if you really want to do reactive, can pump more packets out of the data path. Sorry. Yeah.
Elias Hatim EMC. As you deployed the same services using the new infrastructure, do you have any conclusions in terms of your TCO for the CapEx, OpEx? Can you shed some light on that?
It's less. Yeah, I know. I'd rather not go into numbers, but yeah, it's definitely less.
Okay, that was part A of my question, so I won't ask part A. I might have missed this. In your process, how did you determine which switches to use? Did you develop your own controllers, or did you? I missed the process and how you selected the components.
One of our keys is to use open source. So we went through all the open source controllers. We're using Knox. And one of the big reasons is because the core of sort of developers, the open source community around that today, we built an abstraction layer on top of that to make it easy for us to put our application from one controller to another. And so one of the goals is we're going to open source all this software, and we want other universities to pick it up and use it. We didn't want to tie. We didn't want to tie all the people who want to pick up and use it to a commercial controller for sure, and we wanted to be able to give them choices of what open source or even commercial controllers they put it on. So we build an abstraction layer, and then anyone can take that and just change, the back-end components to make the appropriate calls, API calls to the controller they want, but all the application sort of is detached from that through this layer. Switches, it all depends on your requirements, right? So one of our requirements was high density 10 gig. And that really sort of boxes you in terms of your options. A lot of the switches out there today are sort of 10-100, 1,000, more data center oriented switches. It also depends, I think, as Kyle mentioned, what combination of matches you're doing, and which combination you do depending on which product. Which switch product depends on which of those actually get pushed to TCAM and which get done in software on the switch, so you have to be very careful. And so it depends very specifically on your application, and you really need to dig into all the switches and figure out what's going to perform best for your application.
Sarwar from HP again. So I want to push back a little bit on a response you gave a little while ago, maybe 5 questions ago, which was around the network operators just need to get used to using GUIs and tools and forget about CLI from an automation perspective. One of the things I'm seeing in cloud and enterprise, not necessarily campus, because you get a different profile of administrator sometimes, is really the opposite requirement, which is they want programmatic interfaces into everything, right? All the way down to your individual network elements. They're demanding RESTful interfaces. They're asking whether you have sample chef or puppet scripts for certain elements, and really the goal is to be able to tie all this orchestration for server and storage and network together. So I was wondering whether you had any comments with regards to kind of unified orchestration. I mean, you don't want different sets of tools. You don't want you to be able to push one button for server and storage and then have to go to a GUI to do your network stuff.
Oh, absolutely. I mean, that's why I said, I think the big thing of the unified northbound interface out of that equipment. You also don't want to go build, I mean, the reason they want those APIs is they want to go build their own software to tie that into all their other systems, which is what, I think I was saying earlier, but I don't want to go invest a bunch of money in building that, and then when I switch from one switch vendor or one server vendor to another, to have to go rewrite all of that. It has to be a standard interface. People want to build this orchestration layer and tie all these systems together, to do something that's unique to them and ties all this together. And you don't want to build to one proprietary interface to have to go build to another one. It has to be common orchestration interfaces, APIs into all this. So, and to your point about some people do want that. There's certainly other people, not just myself, within our organization that would say the same thing. There's also a contingent that would say the opposite thing. So I think there's both sides, even within most organizations.
Dave Meyer, Cisco. Notwithstanding the question of whether or not northbound API should be standardized or not, this question about what kind of API you get there seems a little bit like old school. Because generally what you're going to do is you're going to use a model-driven approach, and you're just going to have the thing generate CLI, netconf, and whatever other RESTful interface you want. So in general, when I was talking to some people who were building controllers, they said, oh yeah, well we did this and we put a CLI on it. And what it came down to was it was like a console on the thing. So when all this other stuff went wrong. So it's not as if people want a CLI because they want to type CLI on it. It's more like you want a console on the thing in case something goes terrible and you can look at it. And you can almost get that for free if you build it, with the right tool chains and stuff like that.
Yeah. I was just going to say, as controller vendors, and possibly as one of the controller vendors that you spoke to, we actually built all of our stuff with a REST API first, and then we built our CLI on top of our REST API.
And again, from an operator standpoint, there's the provisioning and the operational aspect, And then, as Dave said, there's the 3 o'clock in the morning, the guy in the knock who's trying to figure out why it's just all turned to worms. And he's going to want to get on a CLI and figure out what it is. And so there's the difference between the provisioning, the normal day-to-day operation, and the what the heck is going on? Why are my packets going anywhere where I think they're supposed to go? So it's that console access. And it's the same thing in service provider. The provisioning guys have a different set of API and interface requirements than the break fix guys.
So I think just to wrap up the session, there was one last question that that we sort of asked everybody else in the morning, and just really wanted to ask you as well. If we're sitting here a year from now, what are some of the high order bits you think are going to happen over the next 12 months?
Well, I can't predict the future, obviously, but I think there's a tendency to think that things are going to move, at least for me. In some ways they seem to move fast, in other ways they seem to move slow. I think that we're down, as I was saying earlier, I think we're down to actually doing the work of putting this stuff out there. I think this time last year we were kind of playing with stuff and looking at it and saying, oh wow, you could do this or you could do that, and now we're sort of in the guts of actually rolling this stuff out. I think you'll see certainly more products on the market. Looking at the O&F schedule, certainly more features into the protocol and more products and some more. I would hope initial production deployments.
Well, thanks a ton. This was a great session. Everybody, please help me thank